Hi, this is Math 1050, and this video is going to be over chapter 6b. And for this, we are going to look at measures of variation. For variation, we describe how data values are spread from the center. So in chapter 6a, we looked at the center, how you measure the center. Now we're looking at how far it spreads, the data spreads away from the center. You could have something where you have very small spread, or you have something where you have a very large spread. Okay, and so we have certain measures that are used to kind of show this. All right, first one is your range. This is the difference between the highest and lowest values. It's also one that, because it includes the highest and lowest values, that outliers can cause it to be really far off, a bit more drastic than we would like. But it's a simple one to calculate. You take your highest value, you subtract your lowest value. So if we have the data set given here, example 1, 2, 3, 3, 4, 5, 5, 6, 6, 6, 8, 10, the range is just going to be 10 minus 2, which is 8. So you got a range of 8. We also use what's called a 5-number summary. And in that 5-number summary, we take the lowest value in the data set, which is in our data set will be 2. I put over here 2. That's the low number. We take the high number, which is 10. We take the middle value, which is our median. So let me count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 5, 5. Okay, so our median is 5. And then we take what's called the first quartile and the second quartile. So quartile 1, actually the second quartile is the median. Quartile 3, which is in a sense the median of each side of our data set. So here we have 5 numbers left over. So first quartile is 3. And here 5 numbers, so third quartile is 6. Right, so that's the 5-number summary. And again, the way it is spread out is your low value is your minimum, your high value is your maximum. That's the 0% and 100%, and then it divides out into 4 regions, each 25% wide. Quartile 1 is right there at the 1/4 mark. Quartile 2, which is the median, is right there at 50%, and quartile 3 is your 75%. So again, with our example, we had for the 5-number summary, low was 2, high was 10, median was 5, quartile 1 was 3, quartile 3 was 6. And we can graph it into what's called a box plot, where you have a horizontal number line of all possible values. You put bars where the numbers are, and then including the median, and then between quartile 1 and quartile 3 you connect the top of the bars. Now the bars really don't matter how high they are. Usually you either make them the same, or in this case you see the middle 3 are the same and the ends are a little bit smaller. But it gives us an idea of how much data falls in the center and how much it spreads out. Right. So for this box plot, your low is about 1.5. And this is a totally different data set. Your high is about 13. Your first quartile is at 4. The median's at 8. And your third quartile is at 10. All right, so being able to read this deals with shoe sizes, being able to read this and where the values place is helpful. Right, so we're going to go to another data set. This one has, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has 40 data points. Okay. Mid value is going to be 19. The minimum, the low. High value is going to be 30. Okay. For this, we'll divide this in half. Notice this is all sorted data. So we divide this by half and we look at the two values towards the center. So 24 and 24. We average those. And when you average the middle values, you get a middle value of 24. That's because of these two numbers. For this first quartile, we divide the top half in half. We average the 22 and 23. And you get a 22.5. 24. And then the third quartile, you get average the 26 and 26. So you get a 26. Alright, so we can draw this out. We'll first make a horizontal axis here. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Put lines at 19, at 30, at 22 and a half. That should be fine where 22 is. Go line 22 and a half, 24, and at 26. Connect this so it makes a box, and then connect the two lower lines midway. And so you have your box plot. When we look at this, one thing we want to see is the more even these two sections are, then it's more normal of a distribution. And then the same thing with these two lines. The more even, the more normal of a distribution. Okay, we start to see skewness when that box is shifted left or right, or when that box has one side that's a lot bigger than the other side. Okay. The other measure of variation is what's called the standard deviation. This is a measure of how far the data values are from the mean. And think of it as the average deviation from the mean. Right, there is an estimate that really is not the best estimate estimate. You take the range, you divide it by 4. We'll do that here in our next example. The actual standard deviation calculation, though, uses this equation where, and this should be squared, where you sum up the differences between x, the data value, and the mean, square each one, and then divide it by your sample size minus 1. All right, so let's look at the 11 values that we have listed. And and we're going to start out with checking the estimate. So the range we found was 8, 10 minus 2. And so your estimate for your standard deviation is 8 over 4, which is 2. Right, we have n equals 11. And we also want to calculate the mean. So when we add these up, your mean, it's going to be, let's see, 10, 18, 24, 30, 36, 41, 50, 56, 58 over 11, which is about 5.27. And then the easiest way to do this is to make a table and find the difference between the data value and that mean. And you don't have to worry about negative sign. It doesn't matter if it's below or above, just whatever the difference is. So between 2 and 5.27 is about 3.27. Between 3 and 5.27 is 2.27. There's a couple of 4 and 5.27 is 1.27. Then it's 0.27 for 5. And 6 would be 0.73. That's 3 of them. For 8, it's 2.73. And then for 10, it's 4.73. All right, now we square each one. So 3.27 squared is 10.69. I'm going to round these. 2.27 squared is 5.15. 1.27 squared is 1.61. And 0.27 squared is 0.07. And there's 2 of these. 0.73 squared is 0.53. 2.73 squared is 7.45. And 4.73 squared is 22.37. All right, and then we add up the total. I get 53.67. So that is your total, 53.67. Then divide by 1 less than the sample size. So we divide this by 10. So your standard deviation squared, or what this is called your variance, is the 53.67 over 10, which is about 5.37. Then we take the square root, and that will give you your standard deviation. Which is going to be about 2.32. Okay. Which it's somewhat close to our estimate of 2. But this is the actual standard deviation. Now, with these on our Desmos. So if you go back to the descriptive statistics calculator, the one that gives us the mean, the median, the standard deviation is there. Our variance, which is the standard deviation squared, is there. And I don't have the range in there, but the ranges you can find pretty easily. So we'll put in the data. 2, 3, 3, 4, 5, 5, 6, 6, 6, 8, and 10. And we see that their mean is 5.27. That's what we found before. Our median was 5, which we found that in the 5-number summary. Our standard deviation was 2.32, 2.33. It rounds a little bit. I remember I was rounding all those numbers, so it's going to be a little bit off. Our variation is about 5.42. That's a little bit higher as well, but not by much. Okay. Your minimum is 2. Your maximum is 10. Then we have the quartiles. D1 is 3. D2 is 5. D3 is 6. We'll not get into this last one right now. The box plot is also on here, and we can zoom and find it. It's listed, it shows it here, so we can see this is the mean skewed a little higher here, and the other side's also skewed kind of high. So this is the standard deviation is a tough calculation. This is the easier way to gain that calculation. All right, we also have what's called the range rule of thumb, which is a way to find what's called usual values. Don't consider them the same as min and maximum. This is the min usual, the max usual. So anything that would be too high or too low will be taken out of this. The calculation's pretty straightforward. It's your mean minus 2 times standard deviation, and your mean plus 2 times standard deviation. So in our case, we're going to have the mean that is 5.27 minus 2 times our standard deviation is 2.32, and we do 5.27 plus 2 times 2.32. Okay, the upper one is 9.91. And the lower one is 0.63. Okay. So what this means is values of 2, 2, 3, 4, 5, 6, and 8 are all considered usual values. Right, 10 is unusual. Right, now, this also does not mean 10 is an outlier. There's a difference. All right, so let me be clear about that. 10 is not necessarily an outlier, it's just unusual. All right, so in this last example, let's look at using this range rule of thumb. We study gas miles of a hybrid under different driving conditions, and we get a mean of 49 miles per gallon with a standard deviation of 4 miles per gallon. And so we're going to estimate the minimum and maximum gas mileage for this vehicle. So your min, usual, is going to be 49 minus 2 times your standard deviation, which is 4, and your max usual is 49 plus 2 times the standard deviation. So top one you get 41, the max usual you get 57. So anywhere between 41 and 57 miles per gallon will be considered usual. If the car's not getting that, maybe something's wrong with it. If it's getting more than that, I don't really know why it would, but maybe the driver knows how to drive in such a way. But that's how you would calculate the usual values. Alright, in chapter 6C, we'll start looking more at the normal distribution. I'll see you then. Bye.